Good evening, guys. Am I audible?
Yes, sir. Good evening.
Yes, sir.
So, shall we get started? Are you able to see my screen as well?
Yes, sir.
Yes, sir.
We'll get started then. Okay. So, the next chapter that we need to discuss is current electricity. So, listen. First, in the part current electricity, what are all the basic terms that are there? One is electric current. So, how do you define electric current as? It is defined as the rate of flow of charge. So, I is equal to Q by T is one mathematical term. And you will write Q is equal to N into E. So, I can also be written as N into E divided by T. Right. Second is, if suppose an electron is revolving in a circle of radius R with speed V, then how do you calculate the period of revolution? So, if suppose there is an electron that is revolving in a circular orbit with speed V, then we calculate the time period as the total distance traveled divided by the speed. That is 2 pi R divided by V. Right. So, what is going to be the frequency of revolution? Frequency of revolution will be V divided by 2 pi R. Right. Similarly, what is current? Current is Q by T or NE divided by T or NE into, can I write it as F? So it will be NE into, what is the value of F? It will be V divided by 2 pi R. So NE into V divided by 2 pi R, right, is also the charge that is carried by N electrons in one revolution. If the electron is going to be 1, it is going to be E into V divided by 2 pi R. Am I clear with this point?
Yes, sir.
Okay. So based on this, can we try out few problems? See, I'm not concerned about the calculation part. I just need to apply the formula. Let's see how to do it. 10 power 20 electrons, each having a charge of 1.6 into 10 power minus 19 coulomb, pass from a point A towards another point B in 0.1 seconds. What is the current in ampere? What is it? What is its direction? So there is an electron moving from point A to point B. So if electron is moving from A to B, what would be the direction of current?
From B to A.
So this is the
Opposite.
direct opposite. So that is there. And we need to calculate the magnitude of it. I is equal to Q divided by T. So what is the value of Q? It is N into E divided by T. So N is 10 power 20 into E is 1.6 into 10 power minus 19 divided by T is going to be 0.1. So it is going to be 1.6 into 10 power 1 divided by 10 power minus 1. So 1.6 into 10 power minus 2, 10 power 2, answer will be 160 ampere. Clear? It's simple, no? So the current flowing is going to be 160 ampere if 10 power 20 electrons are going to cross a point in 0.1 seconds. Shall we go to the next one?
Yes, sir.
Yes, sir.
Show that 1 ampere is equivalent to...
1 minute, sir. Can you show me? Yes, sir. Got it.
Yeah. Show that 1 ampere is equivalent to 6.25 into 10 power 18 elementary charges. This you know, right? So 1 coulomb is equal to N into E divided by T. So N into 1.602 into 10 power minus 19 divided by 1, which implies N will be equal to 1 divided by 1.6 into 10 power minus 19, which will be 6.25 into 10 power 18 electrons. Okay. Shall I proceed?
Yes, sir.
See, the one we solved already in electrostatics itself. So how many electrons pass through a lamp in 1 minute? If the current is 300 milliampere. So 300 into 10 power minus 3 is equal to N into 1.6 into 10 power minus 19 divided by 1 minute is 60 seconds. So n will be how much? 300 into 10 power minus 3 into 60 divided by 1.6 into 10 power minus 19. So calculating this, you will get the number of electrons. So that part I'm leaving it to you. Calculation, you can do it later. These are all very simple problems, right? Next. How many electrons per second? So number of electrons per second is basically current. So how many electrons flow through a filament of potential difference 120 volt and power 600 watt? So what is the relation between power and voltage? Power, voltage and current. P is equal
Sir,
to
60 watt.
V into I. 60, okay. So power is 60 watt, which implies 60 is equal to V is 120 into I, which implies I is equal to 0.5 ampere. So half ampere flows. That's it. But they're asking the number of electrons per second. So calculate N divided by S. So N divided by S is equal to 0.5 divided by 1.6 into 10 power minus 19. Did you understand what I did? N into E divided by S is 0.5. I took the E to the other side. So 0.5 divided by 1.6 into 10 power minus 19. This will give us half into 6.25 into 10 power 18. So it should be 3.125. So it will be 3.125 into 10 power 18. Did you understand what I did? 1 by 1.6 into 10 power minus 19 is 6.25 into 10 power 18, because that constitutes to 1 coulomb of charge, right? So 0.5 I wrote it as half. Multiplying both will give us 3.125 into 10 power 18 electrons per second. Clear? Shall I proceed?
Yes, sir.
Okay. Do this. So this one will help you for atoms chapter as well. In the Bohr's model of hydrogen atom, the electron revolves around the nucleus in a circular path of radius 5.1 into 10 power minus 11 meter at a frequency of 6.8 into 10 power 15 revolutions per second. Calculate the equivalent current. So I will be equal to how much? E into F. So E is 1.6 into 10 power minus 19 into, what is the value of F? It is 6.8 into 10 power 15.
Sir, how sir E into F?
Because E divided by T. How many electrons here? It is only one electron. So N is 1. So 1 into E divided by T. This will be equal to 1 divided by T is frequency. Here actually this T represents the time period. So I'll show you, see. We
Okay,
saw this,
sir,
no?
understood.
We saw this, no? This logic. Got it? So here unwanted data is the radius. You don't need it. Okay. So you'll get the value, that part you calculated later. Next. So the next concept that we are going to see is problems that are based on Ohm's law, concept of resistance, resistivity, conductance, conductivity, current density. Color code is deleted, not there. So don't worry about it. Okay. So what does Ohm's law state? At constant temperature, the potential difference is directly proportional to the current. So R is equal to V is equal to IR, or R will be equal to V by I. So resistance of a uniform conductor, if I take a uniform conductor into consideration, so resistance will be equal to rho into L divided by A, where rho is the resistivity, L is the length of the conductor, and A is the area of cross section. Right? So suppose you want to find the resistivity, then you will write it as R into A divided by L. Conductance is 1 by R. Conductivity is 1 by rho, or L divided by R into A. So what is current density? Current density is the amount of current flowing per unit area. So I divided by A is going to give us current.
That one got dark. Not gonna lie. But hey,
What happened?
Sorry, sir. My mic got on.
Okay. Potential difference is measured in volt, current is measured in ampere, resistance is measured in ohm, and resistivity is measured in ohm meter. Conductance is measured in ohm inverse or mho or Siemens. Similarly, conductivity is measured in ohm inverse, meter inverse, or Siemens meter inverse, and current density is measured in ampere per meter square. Right? Having this information, let's try to solve the problems. So it's not alpha. In a discharge tube, the number of hydrogen ions drifting across a cross section per second is 1 into 10 power 18, while the number of electrons drifting the opposite direction across the same cross section is 2.7 into 10 power 18 per second. If the supply voltage is 230 volt, what is the effective resistance of the tube? So how to calculate it? The number of hydrogen ions drifting across a cross section per second is 1 into 10 power 18. So here, if you need to find the effective resistance, you can do it by using V divided by I. So V is given as 230. But for you to find the amount of current, what you need is, you need the total number of charges that are constituted in this charge, in this process. While the number of electrons drifting in the opposite direction across another cross section is 2.7 into 10 power 18. So how will you calculate the total charge? So what are the total charge, guys? Number of electrons plus the number of protons. Am I right? So number of electrons plus number of protons into charge of each particle. So what are the number of protons that are flowing? 1 into 10 power 18. Plus the number of protons are 2.7 into 10 power 18. Into what is the charge of each electron? 1.6 into 10 power minus 19. So how much will the answer be? 3.7 into 1.6 into 10 power 18 into 10 power minus 19. Right? That is going to give me the amount of charge. But here, observe, read the question carefully. They didn't give us the number of electrons, or they didn't give us the number. It is the number per second. The charge per second is actually what? It is going to be the current. Guys, are you able to understand what I'm saying? So this is actually not total charge. It is the total charge per unit time. It is the total charge per second. Am I clear with this or not? Please get it clarified if there
Yes,
is any
sir.
doubt. Yes. So once you calculate this value of I, let us say this comes, okay, let us say this is I only. Take this value and substitute it here and calculate the effective resistance. So that part you guys can do it, right?
Sir,
Tell me.
sir, usually we don't take into account the number of protons. No, sir.
No,
Why in this question?
because here, it's not like it is an atom. You will not take the
Yes.
charge of electron. It is not an atom. Atom le dhaan the electrons constitute to the charge is what we say. Electrons are lost or gained. But here, it is a discharge tube. Inside the discharge tube, protons are also contributing to the current and electrons are also contributing to the current. So here you need to take both into consideration.
Okay, sir.
When you should not take solar
When we are talking about atom.
atom. Got it? Sorry, next problem, Bolama. Yeah. Yes. So 10-volt battery of negligible internal resistance is connected across a 200-volt battery and resistance of 38 ohm as shown in the figure. Find the value of the current in the circuit. So tell me how to do this. So what is the effective voltage? So what is the effective voltage? It is 200 minus 10. Am I right? Why did I subtract both?
Sir, because the positive is connected to the positive.
Yes. So this one will supply, let's say, current I1. This will supply current I2. They both will get subtracted. That is why the effective voltage will be 190 volt. And resistance is going to be 38 ohm. Find the value of the current in the circuit. I is equal to V divided by R. So 190 divided by 38, which is going to be 20 ampere. Correct? I think this 380 by 19 is 20. 190 by 38 should be 5 ampere.
Sir,
Ah,
sir, if the diagram is not given, we can assume they are, we can add both potentials, sir.
diagram is not given. First of all, you will not take 10 into consideration at all. You will
Okay, sir.
directly write 200 by 38.
Okay, sir.
Okay. Yeah. Oh, here they have mentioned 10-volt battery. So if they mention
Yes.
it, they have to give the diagram, or else they have to mention it in a statement. Ilana, you can't solve.
Okay, sir.
Yeah. Next. There is a copper wire of radius 0.1 millimeter, which is 0.1 into 10 power minus 3 meter, and resistance of 1 kilo ohm, 1 into 10 power 3 ohm, is connected across a power supply of 20 volt. V is equal to 20 volt. How many electrons are transferred per second between the supply and the wire at one end? So what do you mean by electrons per second? You need to find N divided by S. Number of electrons per second between the supply and the wire at one end. So how do you calculate it, guys? For that, you need to calculate the amount of current. I is equal to V by R. So I is equal to V by R. V is how much? 20 divided by R is 10 power 3. So can I write it as 20 into 10 power minus 3? And this will be equal to number of electrons into the charge of each electron divided by time. So N by T is what is going to give you the number of electrons per second. So N by T will be equal to 20 into 10 power minus 3 divided by 1.6 into 10 power minus 19. So what will be the answer? This will give you the number of electrons transferred per second. Second, current density. So for current density, what will I get? I'll get it as I divided by A. So what is the value of I? I is 20 into 10 power minus 3 divided by, how do I calculate the A? What does this A stand for? This A stands for the cross-sectional area. What is the cross-sectional area of a wire? It is pi r square. So 20 into 10 power minus 3 divided by pi is 22 by 7 into, what is the value of r square? R square. 10 power minus 4 the whole square. So solve this. That will give you the answer for current density in terms of ampere per meter square. That part you can do it, right?
Yes, sir.
Okay. See, I'm little fast here because these are all direct applications. I need to concentrate more on circuits. Shall I proceed?
Yes, sir.
Do this. So current flows through a constricted means a conductor which has a varying cross-sectional area. Constricted conductor, the diameter D1 is 2 millimeter, and the current density to the left of the constriction is 1.27. So J1 is equal to 1.27 into 10 power 6 ampere meter power minus 2. What is the current that flows into the constriction? So current is J1 into A1. So that is 1.27 into 10 power 6 into what is the value of area? Area is 3.14 into R square. What is the value of R square? 1 into 10 power minus 3 the whole square. So it is 1.27 into 10 power 6 into 3.14 into 10 power minus 6. Cancel this, cancel this. So 1.27 into 3.14. How much will be the answer? That will give you
Four,
how much?
4, sir. Approximately 4.
4. Sorry. Okay. 4. If the current density is doubled as it emerges from the right side of the constriction, what is the diameter D2? So, if now whatever current is entering here should be the amount of current that is leaving here. Because here you're talking about what kind of current flow? You're talking about steady flow. Correct? So, during steady flow, what should happen is whatever is the current that is passing through the bigger cross-sectional area should be the same current that is passing through the smaller cross-sectional area as well. So if that is the case, can I write J1 into A1 is equal to J2 into A2? Can I? So J1 into, what do I write the value? Okay, A1 one then another. It is pi into 10 power minus 6 is equal to, what did they say J2 is? If the current density is doubled, means it should be 2 times J1 into pi into, what is the value of, so how do you write the diameter? How do you write the formula for area of circle with diameter? It is D square by 4, correct? Am I right? So pi and pi are gone, J1 and J1 are gone, this 2 will cancel this. So D square will be equal to 2 into 10 power minus 6, which implies D will be equal to square root of 2 is 1.4 into this thing is square root of 10 power minus 6 is 10 power minus 3. So it should be 1.4 millimeter. Am I right? Yeah.
Yes, sir.
So it's a good problem actually. Did you understand if this kind of a problem comes, how are you supposed to handle? You can expect this in case study based questions. So in case study, what they'll do is they'll give you the description saying that when current is flowing from one constricted area to another, so yeah, the current density has got doubled and the area has got halved, right? Then what is going to be the value of diameter of the second or something like this? They can frame a question of this sort. Okay. So what are the key criteria here? Whenever this kind of a constriction comes, I is constant. You need to have this in your mind. Right. Next. A current of 2 millimeter is passed through a color coded rejected because color code is not there. Yes. So the next set is we are going to see problems based on drift velocity. Right. So what is the relation between current and drift velocity? I is equal to NEA A BD, where small n stands for what?
The number of electrons.
Is it number of electrons?
Number density.
So it's the number of electrons per unit second.
Yes, sir.
Yeah, sorry, not second, per volume. It's the number of electrons per unit volume. That's what is number density. E is the charge of the electron, A is the area of cross section, and VD stands for the drift velocity. Okay. Then, if you want to write the current density, you write it as J is equal to E N VD, because A will come to the left hand side, I divided by A is going to give you current density, right? See, this is a very rare scenario if at all they ask. Number of atoms in 1 gram atomic mass of an element is equal to Avogadro number of particles, that is 6.023 into 10 power 23. Next is, if you want a formula for resistance in terms of relaxation time, it is given as M into L, where M is the mass, L is the length of the conductor divided by the number density, N into E square into tau into A, or resistivity is given as M divided by N E square tau. Okay. Similarly, relation between current density and electric field. So current density, generally current density is represented with small j. So because that 7 was there, I changed it to capital J. So current density is equal to sigma into E. What does sigma stand for? We saw this already. Sigma is the reciprocal of resistivity. What is it?
Conductivity.
Conductivity. Okay. Suppose you write E, E will be equal to 1 by sigma into J. 1 by sigma is rho into J. So this is the relation. This can be a 1 mark question that they can ask in MCQ. What is the relation between current density and electric field? So current density is equal to sigma into E, or electric field is equal to rho into J. Okay, next. Let's try this problem. Assuming that there is 1 free electron per atom in copper, determine the number of free electrons. Determine the number of free electrons in 1 meter cube volume of copper. Density of copper is 8.9 into 10 power 3 kilogram per meter cube. And atomic weight is, see this one, you can reject it. This kind will not come. As I told you, our atomic weight and all, you need not be concerned about. This is there. Yeah. A copper wire has a resistance of 10 ohm. So R is equal to 10 ohm. Area of cross section is 1 millimeter square. Potential difference is 10 volt. Exists across the wire. Calculate the drift speed of the electrons if the number of electrons per cubic meter in copper. That is, the number density is 8 into 10 power 28. So will you be able to calculate? I is equal to NEA VD. Am I right? But how can you write I as? I can be written as V divided by R. So V divided by R is equal to NEA into VD, which implies V is 10 divided by R is also 10 is equal to N is 8 into 10 power 28 into E is 1.6 into 10 power minus 19 into area is 1 millimeter square, that is 1 into 10 power minus 6 into VD. So VD will be equal to 1 divided by 8 into 1.6 into 10 power 11, 10 power 11, 10 power 9 into 1 into 10 power minus 6. So this will be some value, those many meter per second. That value you can calculate with. Right. Calculate the electric field in copper wire of cross-sectional area. So electric field is equal to how much? In a copper wire of cross-sectional area, 2 millimeters square. So area is equal to 2 millimeters square, carrying a current of 1 ampere. They gave the conductivity of copper is 6.25 into 10 power 7. So how to calculate, guys? Just now we discussed the relation. J is equal to, let me see how many of you are able to tell. J is equal to, just now we saw, sigma into E. So how do you calculate J? J is I divided by A is equal to sigma into E. So I is how much? 1 divided by A is 2 into 10 power minus 6 is equal to sigma is 6.25 into 10 power 7 into E. So what will be the value of E? 1 divided by 6.25 into 2 is going to be 12.5 into 10 power 1. Right? So this will give you the answer in terms of volt per meter. That part you can calculate it. Or you can always go through the notes that is given. Right? Shall I proceed?
Yes, sir.
Potential difference of 100 volt, 1 meter long. Calculate the average jet velocity of electrons. Compare it with the thermal velocity. Not needed. So examples, we'll see the next set that is based on mobility of charge carriers. So what is the mobility of charge carriers? So how do you define mobility as? There's another important definition. It is the drift velocity. So if you don't know, please write it down. Mobility is defined as drift velocity per unit electric field. Okay. Next is I is equal to NEA VD. So first of all, yeah, mobility is equal to VD divided by E. So in the place of VD, I can write mu into E. So it will be NEA into mu into E. Right. So this can be taken. Conductivity, this is not needed, don't worry. And this is also needed. What is going to be the unit of mobility? It is meter square, volt inverse, second inverse. Okay. So based on this, let us do a problem. A potential difference of 6 volt is applied across a conductor. So potential difference of 6 volt is applied across a conductor of length 0.12 meter. Calculate the drift velocity of the electrons. If the electron mobility is 5.6 into 10 power minus 6. So how to do this? Mu is equal to, tell me the formula. Mu is equal to
VD by E.
VD by E, which
VD by-
implies VD will be equal to mu into E.
Yes, sir.
So how do you write electric field in terms of potential and length? It is
E equals V by L.
E equal to V by L because of the potential gradient concept. Right. So VD is equal to mu is how much, guys? 5.6 into 10 power minus 6 into what is the value of potential difference? 6 divided by the length is going to be 0.12, or it is going to be 600 divided by 12. So 5.6 into 10 power minus 6 into 600 by 12 is going to give us 50. So it is 56 into 5 into 10 power minus 6. How much is this? 280 into 10 power minus 6 meter per second. Right? Next. So number density of electrons in copper. So number density of electrons in copper is 8.5 into 10 power 28 per meter cube. Determine the current flowing through the copper wire of length 0.2 meter and cross-sectional area 1 millimeter square when connected to a battery of potential difference 3 volt. Mu is equal to 4.5 into 10 meter square volt inverse second inverse, and charge is 1.6 into 10 power minus 19. Okay, what are we supposed to calculate? Determine the current. So I is equal to how much? N E A mu into E, no? Mu into E. So small n is how much? 8.5 into 10 power 28 into the value of small e is 1.6 into 10 power minus 19 into A is 10 power minus 6 into mu is 4.5 into 10. Okay, what is the value of E? E can be written as V by L. So 3 divided by L is going to be 0.2. So that will give you 15. So just multiply everything and write the answer. Those many ampere will be the required answer. See, if there is anything that is not clear, please stop me. Is it clear till this step?
Yes, sir.
Good. Okay, next. Semiconductor not needed. Yes. So next is questions that are based on temperature variation of resistance. So R final is equal to, how do you write it? R initial into 1 plus alpha into delta T. Can I write it like this? Which implies alpha is equal to R final minus R initial divided by R initial into delta T. Okay. So at what temperature would the resistance of the copper conductor be double its resistance at 0 degrees Celsius? So resistance at 0, if I call it as R, resistance at T, if I call it as 2R, right? Then I will write RT is equal to R naught into 1 plus alpha into delta T. So RT is 2R is equal to R into 1 plus alpha into, what is the value of delta T? T final minus 0. Tell me one thing. I have a question, okay? This alpha is there, no? Okay, I'll come to this point. Suppose the temperature is given in terms of Kelvin and alpha is given in terms of per degree Celsius, right? Can I directly subtract the Kelvin values and write it?
Yes, sir.
Why?
Sir, because the degree of 273 minus 373 minus 273 is 100 and 100 minus 0 is also 100, sir.
That's right. So how will you convert degree Celsius to Kelvin?
Plus
By
270.
adding yes, you will add the 273, no? So here and here you will have 273, which will get cancelled. Okay. So alpha and alpha is there. So 2 is equal to 1 plus given alpha for copper is 3.9 into 10 power minus 3 into the final temperature. So 2 minus 1 is equal to 3.9 into 10 power minus 3 into T final, which implies T final is equal to 1 divided by 3.9 into 10 power minus 3, which will be 10 power 3 divided by 3.9. Which should be greater than 250. Because 10 power 3, 3.9, if I approximate to 4, 1000 by 4 is 250. So the answer should be greater than 250 because the denominator is less.
Sir,
Tell me that.
sir, if we need to find any one of the initial or final temperature, then we need to keep it in terms of Kelvin, right?
Not necessary. That's what I'm
All
saying.
the other data are given.
All other is fine. Okay. If alpha when it is measured in terms of degree Celsius inverse or Kelvin inverse. So yeah, when you're writing this alpha or R, whatever you're writing, no, you're actually writing the change in temperature. So yeah. So change in temperature when you're writing, whether you change the temperature in terms of degree Celsius or Kelvin, it is going to be the same value. Now, solra purida.
Yes, sir, it get cancelled.
It will get cancelled. Okay. So based on that, you need to do. So if there is a problem, I'll explain it how to do it. Okay. Does this temperature hold good for all copper conductors regardless of the shape and size? Answer this question. Does this temperature hold good for all copper conductors regardless of the shape and size? Answer. Yes or no?
Yes,
What?
sir.
Why? Yes is okay. What is the reason? Because
Sir, it doesn't depend, temperature doesn't depend upon the shape and size.
alpha is the same. What is it? Because the temperature coefficient of copper of whatever shape and size it is of, it is going to be the same. Because alpha is the same. Surya, shall I proceed? Yeah. Look, I told you, no, it should be greater than 250. 256 is the answer. Nitish, you will get the you will be able to get the answer for this. This is an NCERT problem, by the way. Do this and see. No? So take the data and then do it. The resistance of a platinum wire or platinum resistance thermometer at ice point. Ice point never.
0 degrees.
So 0 degrees Celsius. Initial resistance is 5 ohm. And steam point 100 degrees Celsius. R final level 5.3.
5.79.
5.2.
Oh, sorry. 5.23. Okay.
When the thermometer is inserted in a hot bath, the resistance of the platinum wire, okay, R final dash is equal to 5.75 ohm. Then what would be the temperature at that point? I'll call it as TF dash. Everyone know. So here, if you observe, what is constant throughout the experiment? What is constant? It is
Alpha.
alpha. So what is alpha? R final minus R initial by R initial into delta T. Can I write it like this?
Yes, sir.
So alpha is equal to, if I take this process, R final minus R initial divided by R initial into delta T is how much? 100. That is 0.23 divided by 500. Right? Per degree Celsius. If I write the alpha, taking these two scenarios into consideration, instead of taking these two, what I would do is I'll take the first and the third. Any reason? Did you understand why I'm taking first and third? Because when I calculate the temperature difference, the zero will help me to give the absolute temperature.
Yes, sir.
So 5.795 minus 5 divided by 5 into T final dash. Correct? So how much will this be? 0.795 divided by 5 into TF dash. Okay. Now divide both, equate both, one unknown, one equation, you will get the answer. So 0.23 divided by 500 is equal to 0.795 divided by 5 into TF dash. 5 and this 100 will get cancelled, which implies TF dash is equal to 0.23. Sorry. 0.23 into TF dash is equal to 79.5, which implies TF dash is how much? 79.5 divided by 0.23. Okay, this value you can calculate it, no? That part I'm leaving it to you. Okay, 79.5, I'll write it neatly. Wait, how much is it?
Sir?
79. Solupa.
Sir, we can also take sec TF and TF dash, no, sir, for alpha in the second case.
You can do it.
Using-
It's your. You can do it.
Yes.
It's your wish, but I didn't take it because that 100 will disturb me.
Okay, sir.
Okay. Yeah. I hope you understood the approach. That is more important for me. Is the approach clear, guys? Yes or no?
Yes, sir.
Yes, sir.
So if this question comes, you should be able to solve. It's worth 2 or maximum 3 marks. Okay. Shall I proceed?
Sir, 1 minute, sir, 2
Yeah,
minutes.
please write it down. Write it down. Let me know once you're done. Okay.
Okay, sir. Done, sir.
Done? Yeah. So the next one is answer is 345.65 degrees Celsius. Yeah. Can you try this? So T initial is 150 degrees Celsius. R initial is 133 ohm. T final is 500 degrees Celsius. R final is how much?
Sir, it's 345.8 ohm.
How much is it? 3?
345.8 ohm.
Yeah. 285 something is given. Going here per answer. 258. This is the formula you applied. No, RF is equal to Ri into 1 plus alpha into delta T paniya. 133 into 1 plus alpha is 45 into 10 power minus 4 into delta T 350. This is what you did?
Sorry, sir, I made a calculation error.
Okay. Check it. Check it again and tell me what is the right answer. Are you getting the 258? Validate and tell me. Guys, speed is important. Okay. It's only multiplication. Division means I can understand. Do it fast.
So 342 is
343 தானா?
So 342 is it?
2.7.
அதான் வருதா? அதான் வருதா? No, did we read the question wrong? What did they ask? The temperature, the tungsten, the resistance of the tungsten. I think they made a mistake. I think they made a mistake.
Sir, on the 115 இது பண்ணிட்டாங்க சார். Alpha
No,
T போட்டுருவாங்க.
ஏதுடா?
So R0 into 1 plus alpha T போட்டாங்க சார். Alpha delta T போட்டாங்க.
Yeah, it's actually alpha delta T. There is a mistake.
Sir, RF value they substituted as 133, sir.
Did we? No, I didn't substitute.
No, sir. In the solution, if you
What did he do is he took the absolute temperature into consideration. So the 150 இருக்குல்ல, so for that 150 he took the 0 as a combination. I'll tell you what he did is, if RT is equal to R0 into 1 plus alpha delta T. So
Yes, sir.
RT he took it as 133 is equal to R0, he left it as it is, plus 1 plus alpha into, he took this as T minus 0. And the 0 la தான் வந்துட்டு is R0.
Oh, okay.
He took it like that and then solved it, but you should still get the same answer. You should get what you did is right only. So how much is it? 3?
342.47.
0.4. Okay, okay, that is right. So this is a similar problem. I don't want to waste time on it. Similar. Yes. So at least let's start with the resistors in series and parallel. Okay. So when resistors are connected in series, what is going to be common between them?
Charge.
Right. Capacitor, we use the word charge. For resistors,
Current.
we use current. Current will be the same. Okay. Similarly, when resistors are connected in parallel, potential difference is going to be the same. Right. So this one you need not memorize it. Don't worry about it. Okay. So slowly I'll tell you how to do it. Okay. So you know these formula, right? When resistors are connected in series, it's exactly the reverse of what happens in capacitors. So resistors connected in series, the resistances will get added. For parallel, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus so until 1 by Rn. Having said this, let's try this problem. Determine the voltage drop across the resistor R1 in the circuit given below. Circuit here. This is the circuit. Okay, let us not look at the solution. So 60 is given 18, 5, 10, 10. 18, 5, 10, 10. Correct? 5 is 60. Let's check it once. 18, 5, 10, 10. Sorry, what does he want? Voltage drop across R1. R1 is 18. This is R2, R3, R4. R1, R2, R3, R4. Yes, now we are ready to solve. Determine the voltage drop across the resistor R1 in the circuit given below. So E is 60, R1 is 18, R2 is 10, and R3 is 5 actually. That is not given. Okay. Listen to this carefully. When there is only one cell present in the circuit and multiple resistors are there, okay, you can always proceed that problem using Ohm's law. So what does Ohm's law say? V is equal to IR, correct? So V is 60. I is the current through the circuit. But when you apply Ohm's law, you need to ensure that the circuit has only one resistor. Means what am I supposed to do? I need to find the equivalent resistance of this. Can you find and tell me? It's a mixed combination. R equivalent is equal to, start from the right extreme point. 10 and 5, how are they connected?
Series.
So how much is that going to be?
15.
So it will become 15 here. And here it is 10. And here it is R1. This is 60. Okay. Now this 10 and 15 are connected in parallel. So how much will it be? 150 by 25. It is going to be 6. So 6 and this 18, how are they connected?
Series.
So what will be the value of R equivalent?
24.
24 ohm. So the circuit will look like this. 24 and this is 60. So I is equal to V by R. 60 divided by 24. 20 by 8 or 10 by 4. Wait. Can I write it as 10 by 4? 10 by 4 is going to give me 2.5. So current flowing is 2.5 ampere. They ask the potential difference across the 18 ohm. So how much is the current that is entering here? It is going to be 2.5 ampere. So what is the value of potential drop? V is equal to IR. I is 2.5 into R is 18. So 2.5 is 5 by 2 into 18 is going to be 5 into
40.
9 with 45 volt. Clear? So it will be 45 volt. Okay. If anyone is copying, please do it. Else we'll proceed to one last problem. We'll finish that. Let me know if I can proceed.
Yes, sir.
So read this question. A set of n identical resistors, each of resistance R, when connected in series, have an effective resistance capital X. So equal resistors connected in series, if I call that to be X, then what is that X equal to? Capital X is equal to N into R. When the resistors are connected in parallel, their effective resistance is, can you directly tell me without solving? When identical resistors are connected in parallel, what will be the
R by N.
R by N? Find the relation between X, Y, and R. Okay, so I don't need N. So X into Y will be equal to R square is the answer. Am I right? So this is the required answer. X into Y will be equal to R square. Clear? It's a simple problem. Okay. So we'll wind up with this. So I might need another session. I'll tell you when I can take. I have to finish it before the part test one. So I'll tell you when I can take, and accordingly we'll have. Okay. So we'll wind
Thank
up
you,
with this.
sir. Thank you, sir.
Thank you.